HBase tutorial. Hello, my name is Richard Kirshner with the Simplilearn team. That is www.simplilearn.com. Get certified, get ahead. We're covering the HBase tutorial. What's in it for you in the HBase tutorial? We'll start by covering what is HBase. HBase Use Case, applications of HBase, HBase versus RDBMS, HBase Storage, HBase architectural components, and finally we'll do a quick demo on HBase so you can see some hands-on. Let's start with an introduction to HBase. Back in the days, data used to be less and was mostly structured. You can see we have structured data here. We usually had it like in a database where you had every field was exactly the correct length. So if you had a name field, it was exactly 32 characters. I remember the old Access database in Microsoft. The files were small. If we had hundreds of people in one database, that was considered big data. This data could be easily stored in relational database, or RDBMS. When we talk about relational database, you might think of Oracle, you might think of SQL, Microsoft SQL, MySQL. All of these have evolved, even from back then, to do a lot more today than they did. But they still fall short in a lot of ways. And they're all examples of an RDMS, or relationship database. Then Internet evolved, and huge volumes of structured and semi-structured data got generated. And you can see here with the semi-structured data, we have email. If you look at my spam filter, you know what we're talking about. All the HTML pages, XML, which is a lot of times is displayed on our HTML and help desk pages, JSON. All of this really has just, even in the last, each year it almost doubles from the year before how much of this is generated. So storing and processing this data on an RDBMS has become a major problem. And so the solution is we use Apache HBase. Apache HBase was the solution for this. Let's take a look at the history, the HBase history. And we look at the HBase history. We're going to start back in 2006, November. Google released a paper on Bigtable. And then in 2017, just a few months later, HBase prototype was created as a Hadoop contribution. Later on in the year 2007, in October, first usable HBase along with the Hadoop 0.15 was released. And then in January of 2008, HBase became the subproject of Hadoop. And later on that year in October, all the way into September the next year, HBase was released, the 0.81 version, the 0.19 version, and 0.20. And finally, in May of 2010, HBase became Apache top-level project. And so you can see in the course of about 4 years, HBase started off as just an idea on paper and has evolved all the way till 2010 as a solid project under the Apache. And since 2010, it's continued to evolve and grow as a major source for storing data in semi-structured data. So what is HBase? HBase is a column-oriented database management system derived from Google's NoSQL database, Bigtable, that runs on top of the Hadoop file system, or the HDFS. It's an open source project that is horizontally scalable, and that's very important to understand, that you don't have to buy a bunch of huge expensive computers. You're expanding it by continually adding commodity machines. And so it's a linear cost expansion as opposed to being exponential. NoSQL database written in Java, which permits faster querying. So Java is the backend for the HBase setup. And it's well suited for sparse data sets. So it can contain missing or NA values, and this doesn't boggle it down like it would another database. Companies using HBase. So let's take a look and see who is using this NoSQL database for their servers and for storing their data. And we have Hortonworks, which isn't a surprise because they're one of the, like Cloudera, Hortonworks. They are behind Hadoop and one of the big developments and backing of it. And of course, Apache HBase is the open source behind it. And we have Capital One as banks. You also see Bank of America, where they're collecting information on people and tracking it. So their information might be very sparse. They might have one bank way back when they collected information as far as the person's family and what their income for the whole family is and their personal income, and maybe another one doesn't collect the family income. As you start seeing where you have data that is very difficult to store, where it's missing a bunch of data. HubSpot's using it, Facebook, certainly all of your Facebook, Twitter, most of your social medias are using it. And then of course there's JP Morgan, Chase and Company, another bank that uses the HBase as their data warehouse for NoSQL. Let's take a look at an HBase use case so we can can dig a little bit more into it to see how it functions. Telecommunication company that provides mobile voice and multimedia services across China. The China Mobile. And China Mobile, they generate billions of call detailed records, or CDR. And so these CDRs and all these records of these calls and how long they are and different aspects of the call, maybe the tower they're broadcasted from, all of that is being recorded so they can track it. Traditional database systems were unable to scale up to the vast volumes of data and provide a cost-effective solution. No good. So storing and real-time analysis of billions of call records was a major problem for this company. Solution? Apache HBase. HBase stores billions of rows of detailed call records. HBase performs fast processing of records using SQL queries. So you can mix your SQL and NoSQL queries. And usually you just say NoSQL queries because of the way the query works. Applications of HBase. One of them would be in the medical industry. HBase is used for storing genome sequences, storing disease history of people of an area, and you can imagine how sparse that is as far as both of those. A genome sequence might only have pieces to it that each person is unique or is unique to different people. And the same thing with disease. You really don't need a column for every possible disease a person could get. You just want to know what those diseases those people have had to deal with in that area. E-commerce. HBase is used for storing logs about customer search history, performs analytics and target advertisement for better business insights. Sports. HBase stores match details and the history of each match. Uses this data for better prediction. So when we look at HBase, we all want to know what's the difference between HBase versus RDBMS. That is a relational database management system. HBase versus RDBMS. So the HBase does not have a fixed schema. It's schemaless. Defines only column families. And we'll show you what that means later on. An RDBMS has a fixed schema which describes the structure of the tables. And you can think of this as you have a row and you have columns. And each column is a very specific structure, how much data can go in there and what it does. With the HBase, it works well with structured and semi-structured data. With the RDBMS, it works only well with structured data. With the HBase, it can have denormalized data. It can contain missing or null values. With the RDBMS, it can store only normalized data. Now you can still store a null value in the RDBMS, but it still takes up the same space as if you're storing a regular value in many cases. And it also, for the HBase, is built for wide tables. It can be scaled horizontally. For instance, if you were doing a tokenizer of words and word clusters, you might have 1.4 million different words that you're pulling up and combinations of words. So with an RDBMS, it's built for thin tables that are hard to scale. You don't want to store 1.4 million columns in your SQL. It's going to crash and it's going to be very hard to do searches. With the HBase, it only stores that data which is part of whatever row you're working on. Let's look at some of the features of the HBase. It's scalable. Data can be scaled across various nodes as it is stored in the HDFS. And always think about this, it's a linear add-on. For each terabyte of data, I'm adding on roughly $1,000 in commodity computing. With an enterprise machine, we're looking at about $10,000 at the lower end for each terabyte of data. And that includes all your backup and redundancy. So it's a big difference. It's like a tenth of the cost to store it across the HBase. It has automatic failure support. Write-ahead log across clusters, which provides automatic support against failure. Consistent read and write. HBase provides consistent read and write of the data. It's a Java API for client access. Provides easy to use Java API for clients. Block cache and Bloom filters. So the HBase supports block caching and Bloom filters for high volume query optimization. Let's dig a little deeper into the HBase storage. HBase column oriented storage. And I told you we're going to look into this to see how it stores the data. And here you can see you have a row key. And this is really one of the important references is each row has to have its own key or your row ID. And then you have your column family. And in here you can see we have column family 1, column family 2, column family 3. And you have your column qualifiers. So you can have in column family 1, you can have 3 columns in there. And there might not be any data in that. So when you go into column family 1 and do a query for every column that contains a certain thing, that row might not have anything in there and not be queried. Where in column family 2, maybe you have column 1 filled out and column 3 filled out, and so on and so forth. And then each cell is connected to the row where the data is actually stored. Let's take a look at this and what it looks like when you fill the data in. So in here we have a row key with a row ID, and we have our employee ID 123. That's pretty straightforward. You probably would even have that on an SQL server. And then you have your column family. This is where it starts really separating out. Your column family, you might have personal data, and under personal data you would have name, city, age. You might have a lot more than just that. You might have number of children, you might have degree, all those kinds of different things that go under personal data. And some of them might be missing. You might only have the name and the age of an employee. You might only have the name, the city, and how many children, and not the age. And so you can see with the personal data, you can now collect a large variety of data and store it in the HBase very easily. And then maybe you have a family of professional data, your designation, your salary, all the stuff that the employee is doing for you in that company. Let's dig a little deeper into the HBase architecture. And so you can see here what looks to be a complicated chart. It's not as complicated as you think. From the Apache HBase, we have the Zookeeper, which is used for monitoring what's going on. And you have your HMaster. This is the HBase master assigns regions and load balancing. And then underneath the region, or the HBase master, then under the HMaster, or HBase master, you have your region server serves data for read and write. And the region server, which is all your different computers you have in your Hadoop cluster, you'll have a region, an HLog, you'll have a store, memory store, and then you have your different files for HFile that are stored on there. And those are separated across the different computers. And that's all part of the HDFS storage system. So when we look at the architectural components or regions, and we're drilling down a little bit, HBase tables are divided horizontally by a row. So you have a key range into regions. So each of those IDs, you might have IDs 1 to 20, 21 to 50, or whatever they are. Regions are assigned to the nodes in the cluster called region servers. A region contains all rows in the table between the region start key and the end key. Again, 1 to 10, 11 to 20, and so forth. These servers serve data for read and write. And you can see here we have the client and the get sends it out, and it finds out where that start, if it's between which start keys and end keys, and then it pulls the data from that different region server. And so the region signed data definition language operation, create, delete, are handled by the HMaster. So the HMaster is telling it, what are we doing with this data? What's going out there? Assigning and reassigning regions for recovery or load balancing and monitoring all servers. So that's also part of it. So, if your IDs, if you have 500 IDs across 3 servers, you're not going to put 400 IDs on server 1 and 100 on the server 2 and leave region 3 and region 4 empty. You're going to split that up, and that's all handled by the HMaster. And you can see here it monitors region servers, assigns regions to region servers, assigns regions to region servers, and so forth and so forth. HBase has a distributed environment where HMaster alone is not sufficient to manage everything. Hence, Zookeeper was introduced. It works with HMaster. So you have an active HMaster which sends a heartbeat signal to Zookeeper indicating that it's active. And the Zookeeper also has a heartbeat to the region servers. So the region servers send their status to Zookeeper indicating they are ready for read and write operation. Inactive server acts as a backup. If the active HMaster fails, it will come to the rescue. Active HMaster and region servers connect with a session to Zookeeper. So you see your active HMaster selection, your region server session. They're all looking at the Zookeeper keeping that pulse. An active HMaster and region server connects with a session to the Zookeeper. And you can see here where we have ephemeral nodes for active sessions via heartbeats to indicate that the region servers are up and running. So let's take a look at HBase read or write going on. There's a special HBase catalog table called the meta table, which holds a location of the regions in the cluster. Here's what happens the first time a client reads or writes data to HBase. The client gets the region server, the host, the meta table from Zookeeper. And you can see right here the client has a request for your region server and goes, hey, Zookeeper, can you handle this? And the Zookeeper takes a look at it and goes, meta location is stored in Zookeeper. So it looks at its metadata on there. And then the metadata table location is sent back to the client. The client will query the meta server to get the region server corresponding to the row key if it wants to access. The client caches this information along with the meta table location. And you can see here the client going back and forth to the region server with the information. And it might be going across multiple region servers depending on what you're querying. So we get the region server for row key from the meta table. That's where that row key comes in and says, hey, this is where we're going with this. And so once it gets the row key from the corresponding region server, we can now put row or get row from that region server. Let's take a look at the HBase meta table. Special HBase catalog table that maintains a list of all the region servers in the HBase storage system. So you see here we have the meta table. We have a row key and a value, table key, region server. So the meta table is used to find the region for the given table key. And you can see down here, our meta table comes in, is going to figure out where it's going with the region server. And when we look a little closer at the write mechanism in HBase, we have write ahead log, or WAL as you abbreviate it. Kind of a way to remember WAL is write ahead log. It's a file used to store new data that is yet to be put on permanent storage. It is used for recovery in the case of failure. So you can see here where the client comes in and it literally puts the new data coming in into this kind of temporary storage, or the WAL on there. Once it's gone into the WAL, then the memory store, mem store, is a write cache that stores the new data that has not yet been written to disk. There is one mem store per column family per region. And once we've done that, we have 3 ACK. Once the data is placed in mem store, the client then receives the acknowledgement. When the mem store reaches the threshold, it dumps or commits the data into HFile. And so you can see right here, we've taken it's gone into the WAL then sorts it into the different memory stores, and then the memory stores, it says, hey, we're ready to dump that into our H files, and then it moves it into the H files. H files store the rows of data as stored key value on disk. So here we've done a lot of theory. Let's dive in and just take a look and see what some of these commands look like and what happens in our HBase when we're manipulating a NoSQL setup. So if you're learning a new setup, it's always good to start with, where is this coming from? It's open source by Apache. And you can go to hbase.apache.org and you'll see that it has a lot of information. You can actually download the HBase separate from the Hadoop, although most people just install the Hadoop because it's bundled with it. And if you go in here, you'll find a reference guide, and so you can go through the Apache reference guide. And there's a number of things to look at, but we're going to be going through Apache HBase shell. That's what we're going to be working with. And there's a lot of other interfaces on the setup, and you can look up a lot of the different commands on here. So when we go into the Apache HBase reference guide, we can go down to read HBase shell commands from a command file. You can see here where it gives you different options of formats for putting the data in and listing the data. Certainly you can also create files and scripts to do this too. But we're going to look at the basics, and we're going to go through this on a basic HBase shell. And one last thing to look at is, of course, if you continue down the setup, you can see here where they have more detail as far as how to create and how to get to your data on your HBase. Now, I will be working in a virtual box, and this is by Oracle. You can download the Oracle virtual box. You can put a note in below for the YouTube, as we did have a previous session on setting up virtual setup to run your Hadoop system in there. I'm using the Cloudera Quick Start installed in here. There's Hortons. You can also use the Amazon Web Service. There's a number of options for trying this out. In this case, we have Cloudera on the Oracle virtual box. The virtual box has Linux CentOS installed on it, and then the Hadoop has all the different Hadoop flavors, including HBase. And I bring this up because my computer is a Windows 10. The operating system of the virtual box is Linux, and we're looking at the HBase data warehouse. And so we have 3 very different entities all running on my computer. And that can be confusing if it's the first time in and working with this kind of setup. Now, you'll notice in our Cloudera setup, they actually have some HBase monitoring. So I can go underneath here and click on HBase and master, and it'll tell me what's going on with my region servers. It'll tell me what's going on with our backup tables. Right now I don't have any user tables because we haven't created any. And this is only a single node and a single HBase store. So you're not going to expect anything too extensive in here, since this is for practice and education and perhaps testing out the package you're working on. It's not for really, you can deploy Cloudera, of course, but when you talk about a quick start or a single node setup, that's what it's really for. So we can go through all the different HBase, and you'll see all kinds of different information with Zookeeper if you saw it flash by down here, what version we're working in, since Zookeeper is part of the HBase setup. Where we want to go is we want to open up a terminal window, and And in Cloudera, it happens to be up at the top. And when you click on here, you'll see your Cloudera terminal window open. And let me just expand this so we have a nice full screen. And then I'm also going to zoom in. That way you have a nice big picture and you can see what I'm typing and what's going on. And to open up your HBase shell, simply type HBase shell to get in and hit enter. And you'll see it takes just a moment to load, and we'll be in our HBase shell for doing HBase commands. Once we've gotten into our HBase shell, you'll see you'll have the HBase prompt information ahead of it. We can do something simple like list. And this is going to list whatever tables we have. And it so happens that there's a base table that comes with HBase. Now we can go ahead and create, and I'm going to type in just create. What's nice about this is it's going to throw me kind of a, it's going to say, hey, there's no just straight create. But it does come up and tell me all these different formats we can use for create. So we can create our table and one of our families. You can add splits, names, versions, all kinds of things you can do with this. But let's just start with a very basic one on here. And let's go ahead and create, and we'll call it new table. Let's just call it new TBL for table. New table. And then we also want to do, let's do knowledge. So let's take a look at this. I'm creating a new table and it's going to have a family of knowledge in it. And let me hit enter. And it's going to come up. It's going to take it a second to go ahead and create it. Now we have our new table in here. And so if I go list, you'll now see table and new table. So you can now see that we have the new table and of course the default table that's set up in here. And we can do something like describe. We can describe, and then we're going to do new TBL. And when we describe it, it's going to come up. It's going to say, hey, name, I have knowledge, data block encoding none, bloom filter, row, replication scope, version, all the different information you need. New, minimum version, 0, forever, deleted cells, false, block size, in memory. And you can look this stuff up on apache.org to really track it down. One of the things that's important to note is versions. So you have your different versions of the data that's stored. And that's always important to understand that. We might talk about that a little bit later on. And then after we describe it, we can also do a status. The status says I have one active master going on. That's our HBase as a whole. We can do status summary. And it should do the same thing as status. So we got the same thing coming up. And now that we've created, let's go ahead and put something in it. So we're going to put new TBL, and then we want row 1. You know what, before I even do this, let's just type in put. And you can see when I type in put, it gives us like a lot of different options of how it works and different ways of formatting our data as it goes in. And all of them usually begin with the new table, new TBL. Then we have, in this case, we'll call it row 1, and then we'll have knowledge. If you remember, we created knowledge already, and we'll do knowledge sports. And then in knowledge and sports, we're going to set that equal to cricket. So we're going to put underneath this our knowledge setup. We have a thing called sports in there. And we'll see what this looks like in just a second. And let's go ahead and put in, we'll do a couple of these. Let's see, let's do another row 1, and this time, instead of sports, let's do science. You know, this person not only, we have row 1, which is both knowledgeable in cricket and also in chemistry. So it's a chemist who plays cricket in row 1. And let's see, if we have, let's do another row 1 just to keep it going. And we'll do science. In this case, let's do physics. Not only in chemistry, but also a physicist. I have quite a joy in physics myself. So here we go. We have row 1. There we go. And then let's do row 2. Let's see what that looks like when we start putting in row 2. And in row 2, this person has knowledge in economics. This is a master of business and how, or maybe it's global economics. Maybe it's just for the business and how it fits in with the country's economics. And we call it macroeconomics. So I guess it is for the whole country there. So we have knowledge economics, macroeconomics. And then let's just do one more. We'll keep it as row 2. And this time our economist is also a musician. So we'll put music. And they happen to have knowledge and they enjoy, let's do pop music. They're into the current pop music going on. So we've loaded our database. And you'll see we have 2 rows, row 1 and row 2 in here. And we can do is we can list the contents of our database by simply doing scan. Scan, and then let's just do scan by itself so you can see how that looks. You can always just type in there and it tells you all the different setups you can do with scan and how it works. In this case, we want to do scan new TBL. And in our scan new TBL, we have row 1, row 1, row 2, row 2. And you'll see row 1 has a column called knowledge, science, time step, value crickets, value physics. So it has information as when it was created, when the timestamp is. Row 1 also has knowledge sports and a value of cricket. So we have sports and science. And this is interesting because if you remember remember up here, we also gave it, originally, we told it to come in here and have chemistry. We had science, chemistry, and science, physics. And we come down here, I don't see the chemistry. Why? Because we've now replaced chemistry with physics. And so the new value is physics on here. Let me go ahead and clear down a little bit. And in this, we're going to ask the question, is enabled new table? And when I hit enter in here, you're going to see it comes out true. And then we'll go ahead and disable it. Let's go ahead and disable new table. Make sure I have our quotes around it. And now that we've disabled it, what happens when we do the scan? When we do the scan new table, I hit enter, you're going to see that we get an error coming up. So once it's disabled, you can't do anything with it until we re-enable it. Now, before we enable the table, let's do an alteration on it. And here's our new table. And this should look a little familiar because it's very similar to create. We'll call this test info. And we'll hit enter in there. It'll take just a moment for updating. And then we want to go ahead and enable it. So let's go ahead and enable our new table. So it's back up and running. And then we want to describe. Describe new table. And when we come in here, you'll now see we have name knowledge. And under there we have our data encoding and all the information under knowledge. And then we also have down below test info. So now we have the name test info and all the information concerning the test info on here. And we'll simply enable it. New table. So now it's enabled. Oops, I already did that. I guess we'll enable it twice. And so let's start looking at, well, we had scan new table. And you can see here where it brings up the information like this. But what if we want to go ahead and get a row? So we'll do R1. And when we do HBase R1, you can see we have knowledge science and it has a timestamp, value physics, and we have knowledge sports and it has a timestamp on it, and value cricket. And then let's see what happens when we put into our new table. And in here we want row 1. And if you can guess from earlier, because we did something similar, we're going to do knowledge economics. And then it's going to be, instead of, I think it was what, macroeconomics, it's now market economics. And we'll go back and do our get command and now see what it looks like. And we can see here where we have knowledge economics. It has a timestamp, value, market economics, physics, and cricket. And this is because we have economics, science, and sports. Those are the 3 different columns that we have, and then each one has different information in it. And so if you manage to go through all these commands and look at basics on here, you'll now have the ability to create a very basic HBase setup, NoSQL setup, based on your columns and your rows. And just for fun, we'll go back to the Cloudera, where they have the website up for the HBase master status, and I'll go ahead and refresh it. And then we can go down here and you'll see user tables, table set 1, and we can click on details, and here's what we just did. It goes through, so if you're the admin looking at this, you can go, oh, someone just created new TBL, and this is what they have underneath of it in their new table in there. So some key takeaways. We went into an introduction to HBase. Talked about what is HBase. We looked at some applications of the HBase for storing different information from medical all the way to sports. And we looked at the HBase architectural components and how it all fits together and the HBase write mechanism. And we even followed up with a basic demo in the HBase shell on how to use some of the features. Thank you for joining us today. Again, my name is Richard Kirshner with the Simplilearn team. If you have questions, you can certainly post them in the YouTube down below, or for more information, visit us at www.simplilearn.com. Get certified, get ahead.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.